Good evening to all. Am I audible? Mention in the chat box if you are able to hear me. Okay, let us discuss the theoretical calculations for the verification of Tellegen's theorem of two circuits which have same topology. And the manual of these theoretical calculations which I am going to discuss now is available in my channel. So you can go through the manual if you have not yet written. So those who want the manual, they can go through my channel, which is available in my channel, the manual for this theoretical calculations. So let us see the circuit. So here we are going to take two circuits of same topology. So if you see carefully here, these two circuits, it's a T network. This is a T network. This is also a T network. Okay. So you can see 47 ohms, 47 ohms, 510 ohms, 510 ohms, 2000 ohms and 2000 ohms. So both circuits have same parameters as well as both circuits are similar circuits. So here, one second. This, okay. So I may not give you enough time. Those who want to write it down in your notes, I may not give you enough time. After this class, after this session is over, you can copy it down. Now, whoever have joined the class, just listen to the class. That's all. So here, these two circuits, you can, if you carefully observe, both are of same topology. So we have to verify Tellegen's theorem for these two circuits. So what I'm going to do is I'm going to connect these two circuits together. So if I connect them, this is how it will look like. So I have connected these two circuits and I have given a DC supply to one end of the circuit. On the other end also have connected another DC source. So two DC sources of 30 volts. Both sources have same voltage of 30 volts. We have connected them across both the ends of this connected circuits. So let us assume voltage notation for one of the voltage source is V1 and notation for another voltage source is V2. Okay, so there are two voltage sources here which have been connected here, one on the one end and another on the another end, open ends. Okay, so another open end. So one of the open ends have been short circuited here. So other two open ends which were there, so across them we have connected two sources V1 and V2. So this is our circuit now. We have to verify Tellegen's theorem for this circuit. So in order to verify Tellegen's theorem, so I'm going to use mesh analysis to verify Tellegen's theorem here. Therefore, if you carefully observe here, there are three meshes: mesh 1, mesh 2 and mesh 3 here. Okay, so I'm assuming mesh currents. Okay, so this is my first mesh or loop current. I can say loop 1, loop 2 and loop 3, 3 loops. So I have assumed this In mesh 1, current loop current as I1. In mesh 2, loop current as I2. In mesh 3, loop current as I3. So mesh 1 current, if you observe here, I have assumed it as clockwise. Current direction is I1 is in clockwise direction. I2 also, I have assumed the current direction as clockwise. And for I3, because of this source, okay, I have assumed the direction in anti-clockwise direction of the current in mesh 3. I have assumed it in anti-clockwise direction. So your wish, whichever direction that you want, you can assume. Okay, it's your wish. No need to follow me. Okay, we can assume either all mesh currents, mesh 1, mesh 2, mesh 3 currents in clockwise, or we can assume all mesh currents in anti-clockwise direction. You can assume any of the mesh current in clockwise, any of the mesh current in anti-clockwise. Okay, so for mesh 1 and mesh 2, I have assumed the currents, loop currents as in clockwise direction, whereas for mesh 3, I have assumed the loop current in anti-clockwise direction. Okay. This is it. Now we will apply Kirchhoff's voltage law in each mesh, and we will write the KVL equations. Okay. So I will just copy that circuit here. So now let us apply KVL in mesh 1. Okay, applying KVL in mesh 1. So if you apply KVL in mesh 1, the algebraic sum of source voltages in mesh 1, how many sources are there in this mesh 1? What are all the elements inside mesh 1? V1, R1, R2. These three elements are there. How many sources are there? Only one source is there. So source voltage 30. Okay, whose value is 30. 30 is equal to voltage drop across the passive elements. So how many the passive elements are? R1 and R2 are the passive elements here. So what is the voltage drop across R1? Voltage drop across R1 is I1 into R1. Okay, I1 into R1. What is R1 value? 47 ohms. R1 value is 47 ohms. Therefore, voltage drop across R1 is 47 into I1 plus another element in mesh 1 is R2. R2 value is how much? 2000 ohms. So 2000 into you just observe 2000 is in between what? In between mesh 1 and mesh 2. Therefore, just observe the current direction of both the loop current directions besides to this 2000 ohms. So this current direction is downward. Okay, it is downward. This current direction is downward. What about this current direction? I2 current direction is upward. So both current directions are opposite to each other. Therefore, differential current will flow through 2000 ohms. Since we are writing the loop equations for mesh 1, therefore, and current in mesh 1 is I1, therefore I1 minus I2. So differential current will flow through 2000 ohms. Since we are writing the loop equation for mesh 1 or mesh equation, we can call it as loop equation or mesh equation. So since we are writing the loop equation for mesh 1, so therefore, and we have observed that I1 current is downward, I2 current is upward, both are opposite to each other. So differential current will flow through 2000 ohms resistor. Okay, so we must write I1 minus I2. So 30 is equal to what? 47 I1 plus 2000 I1 minus I2. Okay, now 47 into I1. 47 into I1. Did I say 40 earlier? It is not 40, it is 47 I1. Okay, 47 I1, you just expand this. What do you get? 2000 I1 minus 2000 I2 is equal to 30. So here 47 I1 and 2000 I1, you can add it. You will get 47 I1 minus 2000 I2 is equal to 30. Consider it as equation number 2. Okay, consider it as equation number 2. The first equation, whatever you have written, consider it as equation number 1. So no need to write. After this session, if you want, you can copy it down later. I want to complete this class as quickly as possible. That's why I'm not giving enough time to write it down. Just listen. Later on, you can copy it down. Now let us apply KVL in mesh 2. So applying KVL in mesh 2. So this is our mesh 2. Let us apply KVL in mesh 2. So what are all the elements that are there in mesh 2? 2000 ohms resistor, 510 ohms resistor, 47 ohms resistor, 2000 ohms resistor. There is no source in mesh 2. So source voltage is how much? 0. Source voltage is 0. 0 is equal to 0 is equal to. So let us start with R3. So R3 value is 510. So what is the voltage drop across R3? Voltage drop across R3 is how much? 510 into I2. Voltage drop across R3 is 510 into I2 plus voltage drop across 47 ohms. Okay, that is R4. How much is it? 47 into I2 plus, okay, I'm going to I2 now. I'm sorry, R2 now. So what is the voltage drop across R2? We have already seen differential current flows through 2000 ohms. Okay, across through R2. Therefore, and since we are in mesh 2 now, therefore I2 minus I1. 2000 into differential current. What is it? I2 minus I1 plus another resistor is there, that is R5. Okay, another resistor R5 is there. So let us see the if you observe carefully, this 2000 ohms, that is R5, is in between mesh 2 and mesh 3. So let us observe the loop currents besides to this R5. This I2 current is downward. I3 current, it is also downward. That means that both are in same direction. I2 and I3 current both are in same direction. So we can add those two currents. So 2000 into I2 plus I3. Okay, that's it. I hope you have understood. So 510 into I2, first equation. Okay, voltage drop across 510. Voltage drop across R4. What is it? 47 into I2 plus 2000 into I2 minus I1. That is it. Next voltage drop is 2000 into I2 plus I3. That is equal to 0. Why 0? Because there is no voltage source in this mesh 2. Okay. That's it. So I'll just delete this circuit now. Now we have to expand it. Expand means just we have to simplify it. So 510 I2 I have written as it is plus 47 I2. Here 2000 into I2 minus I1 is there. Just expand this expression. 2000 into I2 minus 2000 into I1 plus 2000 into I2 plus I3 is there. So just expand it. 2000 into I2 plus 2000 into I3 is equal to 0. Now just simplify it. Okay. So if you simplify, you will get 4507 I2 plus 2000 I3 minus 2000 I1. So just write the currents in sequence form. So I have just rearranged these terms. I have written in sequence. So minus 2000 I1 plus 557 I2 plus 2000 I3 is equal to 0. Consider it as equation 4. And I have considered the first equation which I wrote here as equation 3. Okay. Okay, so now let us apply KVL in mesh 3. For that, I will just copy the circuit in that slide. So now you just observe carefully. Look at the circuit. This is our mesh 3. In mesh 3, what all the elements are there? There is a voltage source V2. There is a resistor R6 of resistance value 510 ohms. Another resistor is there, that is of 2000 ohms, that is R5. So only 3 elements are there in mesh 3. So let us write the mesh equation or KVL equation. So here, so I am starting, okay, let us start with the source. Source voltage is how much in this? Algebraic sum of all source voltages in this mesh 3 is only one source, that is 30 volts. So 30 is equal to voltage drop across this resistor, how much? 510 into I3. That's what I have written here, 510 into I3 plus this 2000. 2000 into what? Both the currents, I3 and 2000 is in between mesh 2 and mesh 3. And if you observe the loop currents, I2 and I3, both are in same direction. Okay, both are in same direction. Therefore, 2000 into I2 plus I3 you have to write. So this is our KVL equation. Consider it as equation number 5. Now let me delete this circuit here. So now let us simplify this. So 510 I3, I have kept it as it is. 2000 into I2 plus I3 is there, so just expand it. 2000 into I2 plus 2000 into I3 equal to 30. Just simplify it, you will get 2000 into I2 plus 2510 into I3 equal to 30. Okay, consider it as equation number 6. Now you have equation number 2, equation number 4 and equation number 6. So simplify these 3 equations. Directly you can use the calculator to simplify equation number 2, 4 and 6. Okay, if you simplify using your scientific calculator, you will get I1 value, I2 value and I3 value. So I1 value, what did we get? We have got 0.0198 amperes. Okay, and I2 is 0.00535 amperes and I3 is 0.00768 amperes. You can write it down in milliamperes. Okay, 19.8 milliamperes. I1 is 19.8 milliamperes. I2 is 5.35 milliamperes. I3 is 7.68 milliamperes. If you want, you can convert that into milliamperes. And you can write I1, I2 and I3 in milliamperes. So consider I1, I2 and I3 values and give some notations to them, some numbering, not notation, sorry. Give some numbering to them. Equation number 7, 8 and here it should be 9. I didn't write the 9 here. It is 8 here. It should be 9. So give some numbering to these currents I1, I2 and I3. Now we have determined the loop currents. Okay, we have determined the loop currents. Therefore, now we can start determining the voltage drop across each resistor to verify the Tellegen's theorem. So let us proceed. Now, so first of all, let us write down the current flowing through each resistor to determine the voltage drop. So first of all, what is IR1 current? Current flowing through R1 is nothing but I1, isn't it? What was it? 0.0198 amperes. So what is the current flowing through R2? Current flowing through R2 is the differential current, that is I1 minus I2. So I1 value, what did you get? 0.0198 minus, what is I2 value that you have got? 0.00768. 0.0535. So you just subtract these two, you will get 0.01445 amperes. You can write it as, sorry, you can write it in milliamperes, that is 14.4 in milliamperes. You just convert that amperes into milliamperes and you can write like this. This is small m, capital A, small m, capital A. Okay, so 14.45 milliamperes, that's it. So what is the current flowing through R3? Current flowing through R3 and R4 are same. That is I2 current. So how much current did we get earlier? We have already calculated. How much is it? 0.00535 amperes. So here 2 times I have written amperes. So okay, I will just remove this ampere and I will keep this one. So this is it. You can convert that into milliamperes. I2 current, that is current through R3 and R4. What is the current? 0.00535 amperes. You can convert that into milliamperes. If you convert that into milliamperes, it will be around 5.35 milliamperes. Okay. Next, current flowing through R5. Current flowing through R5 resistor is I2 plus I3. I2 is how much? 0.00535 and plus what is I3 current? 0.00768. Okay. So I3 current is this. So add those two currents, you will get 0.01303 amperes. So what about the current flowing through R6 resistor? Current flowing through R6 is nothing but I3 current. So I3 current is how much? 0.00768 amperes. So this is it. Okay, these are all the currents through each resistor. Okay, these are all the currents through each resistor. Now we know the resistance value, we know the current through each resistor. We can easily determine the voltage drop across each resistor. Okay, so let us see the voltage drop across each resistor. So total how many resistors were there? Total 6. Okay, total 6 resistors were there. So voltage drop across R1, voltage drop across R2, voltage drop across R3, voltage drop across R4, voltage drop across R5, and voltage drop across R6. That's what we have to determine. So what is the voltage drop across R1? IR1 into 47. So what is IR1? 0.0198 into 47. Just simplify it, you will get 0.9306 volts. Okay. Similarly, voltage drop across R2 is IR2 into R2 value is how much? 2000. So IR2 is 0.01445 into 2000. You will get 28.9 volts. Similarly, voltage drop across R3 is IR3 into R3 value is 510. So IR3 is how much? 0.00535 into R3 is 510. So just simplify it, you will get 2.72 volts. Similarly, voltage drop across R4. So what is the voltage drop across R4? IR4 into R4 value is 47. So IR4 is how much? 0.00535 into 47. You will get 0.25 volts. Similarly, voltage drop across R5, that is equal to IR5 into 2000. IR5 value is how much? 0.01303 into 2000. If you simplify, you will get 26.06 volts. Similarly, voltage drop across R6 is IR6 into 510. You will get IR6 value is how much? 0.00768 into 510. You just simplify it, you will get 3.16 volts. So we have determined the voltage drop across each resistor. Okay. So earlier we have determined the current flowing through each resistor. Now we have determined the voltage drop across each resistor. So we have the voltage drops across each resistor and current flowing through each resistor. We can determine the power absorbed by each resistor from this data. Okay, from this data we can determine the power absorbed by each resistor. Okay, so before that, before going for power absorbed by each, determining power absorbed by each resistor, what I have done here is I have first of all calculated the power delivered by the sources. How many sources are there? V1 and V2. Two sources are there in the given circuit. So power delivered by source 1, PV1, is equal to what? Voltage source into current coming out of that source, that particular source. So source value V1 is 30. Current coming out of that particular source was I1 current from source V1. Current coming out of that source was I1 current. I1 current we have already calculated. What is that? That is 0.0198. So just multiply, you will get the power delivered by source 1, that is 0.59 volts. Similarly, okay, similarly power delivered by source 2. Power delivered by source 2 is what? Source voltage V2 into current coming out of that particular source, that is I2 current. So V2 is 30 and I2 current is 0.00768. Just multiply those two, you will get power delivered by source 2, that is 0.23. Sorry, here it was this is not volts, this is watt. So I just did not notice that. Okay, it's watts. Now power units are watts, not volts. So by mistake I wrote V there, and simply I just read the values here. Okay, so what is the power delivered by source V1? So power delivered by source V1 is V1 into I1, that is 30 into 0.0198. So just simplified, you will get 0.59 watts. Similarly, power delivered by source V2 is V2 into I2, that is 30 into I2 value 0.00768, that is 0.23 watts. Okay, so what is the total power delivered? Simply add those two powers. So simply add 0.59 with 0.23. If you add those two, you will get, I think my value here, it was 0.4 and this was 0.594. This is what I got when I did the calculation. Okay, so total power delivered here is how much? 0.594 plus 0.2304, you will get 0.82 watts. So total power delivered by these two sources. Which sources? V1 and V2. Total power delivered is 0.82 watts. That's it. Okay, now we have calculated the power delivered, and we have to calculate the power absorbed by each resistor. So let us see. Power absorbed by each resistor. Total how many resistors were there? Total 6 resistors were there. So power absorbed by resistor R1 is, let us assume the notation PR1 is voltage across resistor R1 and current flowing through resistor R2, that is VR1 into IR1 will give us the power absorbed by R1. So VR1 how much? 0.9306 and IR1 is 0.0198. You just multiply, you will get 0.0184 watts. Similarly, power absorbed by resistor R2, PR2 is VR2 into IR2. VR2 is 28.9, IR2 is 0.01445. Just multiply those two, you will get 0.418 watts. Power absorbed by R3 resistor, PR3 is VR3 into IR3. VR3 is how much? 2.72 into IR3 is 0.00535. Multiply those two, you will get 0.0145 watts. Similarly, power absorbed by resistor R4, PR4. Notation is PR4. You just multiply VR4 into IR4. Okay. You will get VR4 value is 0.25 and IR4 is 0.00535. Multiply these two, you will get 0.0013 watts. Okay. So where is it? 0.0013 watts. So these are the powers absorbed by these 4 resistors. 2 more resistors. Total 6 resistors are there. So I will change this slide. Okay, so these are the powers absorbed by resistor R1, R2, R3 and R4. R5 and R6 are also there. So power absorbed by R5. Where is it? Power absorbed by resistor R5. How much is it? PR5 is equal to VR5 into IR5. VR5 is 26.06. IR5 is 0.01303. You will get 0.34 watts. And power absorbed by resistor R6 is PR6 notation. That is equal to VR6 into IR6. VR6 is 3.16 and IR6 is 0.00768. If you multiply those two, you will get 0.024 watts. Now, what is the total power absorbed by resistor 1, R1, R2, R3, R4, R5, R6? You have to simply add all the resistance values. PR1 plus PR2 plus PR3 plus PR4 plus PR5 plus PR6. Simply add the powers absorbed by each resistor. Okay. What did I write here? Simply add the powers. This is equal to, yeah, okay. So I had a bit confusion here. So if you add all these powers, okay, what you are going to get is 0.8162, which is approximately 0.82. Okay. So what is the power absorbed by the what is the total power absorbed by all the elements here? How much did you get? 0.82. And in the previous slide, power delivered. What was the total power delivered by the sources? How much was it? How much was it? 0.82. Okay. Total power delivered 0.82. Similarly, total power absorbed. Total power absorbed. How much? 0.82 watts. So I didn't write watts here. I will write that. So for power delivered, I have written watts. Here I forgot to write the watts. Okay. So total power absorbed is 0.82 watts. Okay. Total power delivered is 0.82 watts. So if you want to write the theoretical proof for these calculations, so theoretical proof is what? Total power delivered. How much is it? Okay, how much is it? 0.82. So what is the total power absorbed? That is 0.82. So total power delivered must be equal to the total power absorbed. Okay, if that is if that condition is satisfied, then Tellegen's theorem is verified. Okay, if that condition is satisfied, then Tellegen's theorem is verified. So total power delivered must be equal to total power absorbed. I will write it there. I don't want to, I'll make some modifications here. Okay, I just made some modifications. I thought earlier whatever was there, it was not much satisfactory for me. So here, theoretical proof. So what is the total power delivered? Total power delivered is power delivered by source 1 and power delivered by source 2. That is 0.59 plus 0.23. So you just add it, you will get 0.82 watts. So what is the power absorbed? You just add all the powers absorbed by all these resistors. Total 6 resistors are there. So add all the powers, which we have already done actually in the previous slide. You might have seen it. So we have got 0.8162, which is approximately equal to 0.82 watts. So since here, if you observe carefully, total power delivered is equal to total power absorbed. Hence, Tellegen's theorem is verified for the given two circuits of same topology. Okay, so if the total power delivered in the given circuit is equal to the total power absorbed by the circuit elements, so total power delivered by what? Total power delivered by the sources is equal to the total power absorbed by the elements in the given circuit, then Tellegen's theorem is verified. So I didn't give much enough time to copy it down. So those who want, after this session, I am just going to conclude it. So Tellegen's theorem is verified here. So you can copy it down. Those who want, those people can copy it down. I am just going to close this session. So if anyone have any doubts, you can mention in the comment section. Okay. So if you want to go through the manual, you can go to my channel and you can get the manual from my channel. So that's it. Thank you for attending this class.